Hi everyone, welcome to the second video on the application of matrices to simultaneous equations. In this video I'm going to have a look at a couple of worked examples. So first up is worked example 17. So we've got solve the two simultaneous linear equations by matrix methods. So we've got 2 plus 3y equals 13, 5x plus y equals 16. Now, this should actually have a x in front of the 2. So I'm just going to add that in. It should have an x in there. Okay, so to start off with, we want to convert these two equations into matrices into the general form ax equals b. So first thing we want our coefficient matrix. So that's going to be all the numbers in front of the unknowns. So we've got 2, 3, 5, and 1. X is our unknown matrix, so that's going to be x and y. So we've got x and y as our unknowns, so we need those two in there. And on the right hand side we have 13 and 16. So that's your first step, is converting the two equations into matrices into the general form ax equals b. Now the next thing is we've got to look at how do we solve these two simultaneous equations. So like before, in the previous example video, we said we'd need to multiply the inverse of a on the left hand side, and the same thing over here. So we have our unknown is equal to the inverse of a times b. So this is my coefficient matrix A. So to work out what my coefficient matrix A is, I first need to find the determinant. So the determinant of A, so remember A, D, so 2 times 1 minus BC, 3 times 5. So we've got A times D minus B times C. So element A times element D, element B times element C. And if we work that out, we have 2 take 15. So we'll get minus 13. Just as a... Yeah, no, that's fine. Right, so you get minus 13, and we can say our inverse of A is 1 over the determinant times, and we've got to swap A and D around. So over here, so we'll say 1 and 2, they get swapped, and then negatives on the other two. So that's my inverse of A. Now you've got two options here. You can either put the fraction into that matrix, or you can keep it out the front. For this moment, I'll just leave it out the front. So just going back to the start, we've got matrix A times matrix B equals, matrix A times matrix X equals B. And I multiplied by the inverse to A. And when I did that, they'll cancel out each other. So over here, I'm going to be left with X and Y. So I don't need to actually do the multiplication, because it's just going to give me the identity, which is 1. They basically cancel out each other. But over here, I get the inverse of A times b. So my inverse of a, I actually have to put in now. And I multiply that by matrix B, which is just that, the 13 and 16. Now, once I've done that, I need to work out what this matrix times this matrix is. And we can do that by hand because we've got a 2 by 2. Now, this is using a train method or any other method that you know of. So it'll be 1 times 13. I'm not going to draw it all out. So 1 times 13 plus minus 3 times 16. And then minus 5 times 13 plus 2 times 16. Just leaving that fraction out the front for now. And if I work out that, I'll have 13 minus 38. So I'll get about 25 minus 25, and I can't do that in my head, whatever you get there. So that's just a quick little arithmetic. So that's pretty much it. So what I can say is whatever number you get in there, I don't have the calculator next to me. So just to keep the video short as I can, we'll have x and y. So we'll say it might be, could be 17, for example. And then put the fraction in. We'll have x equals, or xy equals 1 over. Alright, it's not very nice numbers. So if I put the fraction in, I'll have minus 25 over minus 13. And we'll have 17 over minus 13 on the bottom. So x is going to be the top one, y is going to be the bottom one. Numbers aren't nice, but that happens sometimes. So that's basically part A. So solving two simultaneous equations, we get x equals this one, x equals the bottom one. Part B, use matrix methods to solve the following. Okay, again, we want AX equals B. So matrix A is going to be the coefficient matrix, so all the numbers next to the coefficients. So we'll have 1, minus 2, 1. We'll have minus 2, 3. And the coefficient of Z in this case is going to be 0. Because we don't have Z in the second equations, it means that its coefficient is 0. And same thing for y in the third equation. We've got no y, so it means the coefficient is actually 0. Then we have x, y, and z equal to minus 2, minus 3, and 4. And that's basically all we need to do in terms of our solving by hand, because we've got a 3 by 3. I could do it by hand. It's not really in this course. If you go onto university and study linear algebra, you'd be able to do that. It is quite complicated. So when we get to this stage, this is our first step. This is required. After that, we'll use our CAS. So we use CAS. So I'm just going to pause the video so I can set up my Casio. Sorry, I don't have the connection to my calculator, um, so I'll try and do it by hand and just show you what we need to do. So remember, we've got ax equals b. We need to multiply the inverse of a on the left. Okay, so those two cancel out. We're left with our x. We need to do the same thing on the other side of the equation. So we multiply b, the inverse of a times b. So that's what we're going to end up doing. And what we have is our unknown matrix on the left-hand side. And on the right-hand side, we're going to have our inverse of A. And on the calculator, basically, we just need to type in our matrix A. So 1, minus 2, 1, minus 2, 3, 0, 2, 0, minus 1. And then just need to tap on the to the power of minus 1. And it'll probably look like, okay, so that little hat button, so to the power of minus 1, and probably put the minus 1 in brackets. It probably won't make much difference, but just to be sure, put it in brackets. So that's what it'll look like on your calculator, and need to multiply that by matrix B, 3 and 4. Okay, so that's what we're doing. Now on your calculator again, you don't need to write this part, so you just need to type in this. So that's what you should have on your screen. Click enter, and we'll get x, y, and z equals 0, minus 1, and 4. So we can say x equals 0, y equals minus 1, and z equals 4. Okay, again, that's all you type on your calculator, but on paper, this is what we actually write. So x, y, and z equals all this, x, y, z equals this. So that's all we need to do in terms of what do we need to write down. Because we're using our CAS, okay, first step we need to actually write down what we're actually doing. So finding the information from the equations, turn it into matrices in the form ax equals b. The next step is, because we're using CAS, we just write x, y, and z equals the inverse of a times b, those matrices. And our final step is just x, y, z equals our answer. And that's part B, that's all we need to do. So really there's only 3 lines that you need to write down, the rest we need to use CAS. Worked example 18. So using a matrix method to decide if the simultaneous equations have unique solutions or not. So as soon as we read this, unique solutions, or that's all we need to find. So when we see that, we need to say, is the determinant equal to 0 or not? So is the determinant equal to 0? After that, that's all we need to find. So first step, again, need to convert our equations into matrices. We've got ax equals b. So matrix A is going to be the coefficients of the unknowns. Now I could write it all out, ax equals b, but I'm just looking at, is the determinant of A equal to 0 or not? So I just need to find what's matrix A, what's 2 minus 1, 1 and 1, what's the determinant of A. I need to work out what's element A times element D, and then take it away from element B times element C. So element A is 2, I multiply that by 1. Element B is minus 1, I'll put it in brackets. Element C is 1. And then just work it out. 2 times 1 is 2. Minus 1 times 1 is 1. 2 negatives make a positive, so it equals 3. So does the matrix A, or does the first simultaneous equations have a unique solution? Yes, because the determinant of A is greater than 0. Or actually, I should say not equal to 0. So that's part I. The next part, we've got matrix A as the coefficients, so 2, 4, 3, and 6. My determinant, element A, which is 2, D, which is 6, B, which is 4, and C, which is 3. Work that out. 2 times 6 is 12. Take 12, it equals 0. So it means that there is no unique solution. Okay, because the determinant equals 0. So that's all we need to do. This part here, because I did get something that's not equal to 0, it means I can find the inverse and solve that equation. But because I got 0 over here, that's as far as I can go. Okay, so I wouldn't be able to solve this equation. Last example, example 19. So worded questions are typically harder than normal routine questions, only because there's extra steps involved. So from the previous video, we talked about when answering types of problems with lots of words, there's a few steps that we can take. So first one, read the problem several times to ensure you fully understand it. So we've got a bakery produces 2 types of bread, wholemeal and rye. The respective processing times for each batch on the dough making machines are 12 minutes and 15 minutes, while the oven baking times are 16 and 12. How many batches of each type of bread should be processed in an 8-hour shift so that both of the dough making machine and the oven are fully occupied? So read that a few times. Second thing is to identify the unknowns and assign suitable pronumerals. So what are the unknowns? We've got wholemeal and rye. So they're 2 types of bread. And we've got time for each of those different ones. So wholemeal and rye are going to be my 2 unknowns. Time is going to be the coefficients. So I'm going to say wholemeal is going to be W, rye is going to be R. I'm going to keep them as capitals. Doesn't really matter, but might be easier to read. So next thing is to identify the statements that define the equations. So just breaking it up a little bit, talking about the respective processing time. So we've got the dough making machine, and it takes 12 minutes to cook the wholemeal. And 15 minutes for the rye. Then we've got the oven baking machine. So we've got 16 minutes for the whole meal and then 12 minutes for the rye. When I add them together, we've got an 8-hour shift, and we want to ensure that both the dough making machine and the oven are fully occupied. Just as a quick little note, I've got to actually talk about time in either hours or minutes. Okay, got to be consistent because the first part says it's in minutes and the second part says it's in hours. I've got to convert one or the other. And it's probably easier to convert 8 hours, hours into minutes. So if I do that, 60 minutes in an hour, 60 times 8 is going to be 480. Okay, so I'm saying the first equation has to be 8 hours, second equation 8 hours, but I'm actually going to talk about it in minutes. So they're both going to be 480. So there's my equation. That's the hardest part of this question, or it's going to be the hardest part, is getting the information and turning it into equations. The third step is to look at the equations and convert those into matrices. Again, AX equals B. We've got coefficient 12, 15, 16, and 12. And we've got W and R, and they're both equal to 480. After that, part 4 is use matrix methods to solve these equations. I'm not going to go through it. You could do it by hand because we've got a 2 by 2. It's probably just easier to use our Casio from the past example shown. So what we would say is our W and R is equal to the inverse of our coefficient matrix. And we multiply that by the 480. And running out of room, but I'll oops. Okay, so that's what we've got. So if we do that in our Casio and work it out, we'll get W and R equal to 15 and 20. Oops. Okay, so W equals 15, R equals 20. So it means that we want 15 batches of the wholemeal bread, and we want 20 batches of the rye. To fully utilize the dough making machine and the oven during the 8-hour shift. That's what we've just solved. So that's example 19, chapter 8.7. Have a go at some of the questions yourself. Feel free to ask questions, either myself or other colleagues. Thanks for watching.